So this, like number 1 is 2, 6. Number 2 is what we're going to talk about today, which is slant asymptote. But it will actually, like, I'm going to do a different one tomorrow because we're going to, like, dig a little deeper in those instead of just finding the actual slant. So we talked about all the parts of the graphs that you got to find, right? So I tend to start with checking to make sure there's no holes, right? Then vertical asymptote, horizontal asymptote, x-intercepts, which are your zeros, y-intercepts. It's going to ask you for domain, and then you're going to graph it, obviously testing any additional points that you need. So for this one, it just said, it said find vertical and horizontal asymptotes, but obviously you need other information in order to graph it. So let's start by making sure this can't be reduced. So I want to see if the top and bottom can be factored and something can be canceled and it's not, right? So there's no holes there. That's when a hole would occur. So then I move on to vertical asymptotes, and the vertical asymptotes come from my denominator. So if this is x plus 4 and x minus 4, then I set them each equal to 0, and I get x equals negative 4 and x equals positive 4. Those are my vertical asymptotes, positive 4, negative 4. Okay, then my horizontal asymptotes come from the relationship between the highest exponent and the top and the bottom, right? So what's true about the relationship this time? They're the same, and so this is the leading coefficient one, right? We do y equals leading coefficient in the top over leading coefficient in the bottom. 4 over 1 would be 4. So now I've got a horizontal asymptote at 4. Let's do these different because they're hard to see. Okay, so it's not enough to graph it yet, right? I do know it's in 3 different parts, and that usually that means the outsides are either both up and the inside's a parabola-ish shape. Doesn't have to be a perfect parabola, but that. Or the outside's one top corner, bottom left corner, top right corner, bottom left, and then the middle is like a cubic shape, right? Those are the kinds of graphs that we can get. But we don't know that yet, okay? Which means we want to use all those other things that help us. It's going to ask you for the zeros, so you might as well find them. And that is by setting your numerator equal to 0. So I get a 4x squared equals 0, x squared equals 0, and x equals plus and minus the square root of 0. So why is it important to know that there's 2 of them? What's that called? The number of times.
Multiplicity.
Good. So why does an even multiplicity matter? How does it help?
It shows what the we know it bounces.
You know it bounces. Good. So if I don't know that, I have to plug in 2 extra points just in the middle, which you want to avoid, right? So if let's say I don't know it bounces, okay, I didn't pay attention to that, then I'm going to have to plug in like, whoa, where did it go? I didn't even know how that happened. Okay. Hi, Sebastian. Totally marked you absent. Just make sure you let your parent know that you are here now. Okay. Yeah.
For the middle one, how do I know if it's upside down or like U-shaped? I don't.
So if it's a parabola, it's going to bounce away usually from your horizontal asymptote. The other way we can know it is we're going to have to plug in something. So this is 1, 2, 3, 4. We're going to have to plug in like -5 and +5 and see what happens there. We also have symmetry here, which could help us eliminate one of those steps as well. So the fact that we still have all that left to do, like personally, I would have remembered that it bounces, and if it bounces, it usually bounces away. And I would have skipped this plugging in of 2 and -2. But if you don't know that, you're going to have to plug in extra. So you plug in like something like 2 and -2. If you know that it bounces, and you know that this is symmetric, because if I plug in a -x here and here, it goes back to the original. So I know this is symmetric to the y-axis. Now I know for sure it has to be a parabola, and it has to have the same directions on the outer bands. So then all I really have to do is plug in like +5. I'd get 5 squared over 5 squared minus 16. 4 times 25, 25 minus 16, 100 over 9. And so that's like 11 and 1/9, right? So I know it's way up here. My curve is doing that. The fact that I know symmetry tells me it would also be up here. And my curve here would be doing that. They all 3 cannot go in the same direction. So I now know that I was right on this one to make it a parabola pointing down. So the symmetry helps you eliminate steps. The bouncing helps you eliminate steps. If you didn't know those two, then you would have had to plug in like +2, -2, +5, and -5. That's a lot of plugging in. But when in doubt, you have to plug them in.
±5 is for the top ones, the curves, right?
Yep.
Okay. And why do we know they have to go there and not under that, like in between that other area?
So they can't all, like this, you mean?
Yeah.
They can't all three go the same direction. It's either
okay.
it's either both up and the parabola down, or they're both down, parabola up, or they're opposite corners and it's a cubic function in the middle.
Okay. And we know that the parabola is going down because the horizontal asymptote up there?
Yes.
Or okay.
Yeah. It's also always opposite your corners. So like once we found 5, we know it's the opposite
Right.
direction. Yep.
Okay. And all that is plugging in after you find everything.
Yep. Go ahead.
So for the upper bounds and lower bounds, it's not really something we need to know. It's just helpful to know, or do we have to know for the business?
The upper bound and lower bound? Say that again. That's for your zeros. Is that what you're talking about? Upper bound, lower bound comes from your roots, like when you're testing your possibles. Is that what you mean, Noah?
Yeah, I think.
Okay.
I thought you said something here.
No. All right, the only other thing I would say, you want to make sure you would know the domain on this, because that's something that's going to ask you, right? Well, the y-intercept, which we would have found to be 0, 0, is going to ask you that, 0, 0. It's not always the same, okay? And then the domain, remember, it's just the opposite of the asymptotes. So where we say the asymptotes occur at equals, we would say the domain can't equal those. So it can't equal -4 or 4, which means -infinity to -4, -4 to +4, and 4 to +infinity. So,
Is Chris Marley?
yeah.
If it was a cubic function, the one in the middle, how would, like, for the bounce one, we know it bounces away from the asymptote, but for the cubic function, how do we know if it's either left up, right down, or the other way around? Is there any way?
You got to plug in points.
Okay.
Yeah, so you'll plug in a point to the left of that middle to see if it goes up or down, and then the right of that middle to see if it goes up or down. Good? Yeah? Okay, so we're going to finish, and then if we've got questions, I'll come back to it. This is a glimpse at your week ahead of you. So today, obviously, we're going to finish the 2-7 part of the notes. Your homework tonight's going to be that part 2. And then tomorrow, we're going to finish the warm-up. So I'll actually probably do a different warm-up. I have a better review that's got a bunch of those examples. We'll do that tomorrow or Wednesday, depending on time. And then we'll start your test review tomorrow. I'll go over questions on that review Wednesday, sorry. And then test is Thursday. This is going to be that first part, which has the graphs that we just did, and then it's got a little bit of the zeros, but we'll talk about that tomorrow. And then Friday, so the first group of standardized tests comes with the juniors next week are going to do their PSAT. The following week, the seniors have the ACT. The following week, the sophomores have their PSAT. So I'm going to try to just do one day of kind of reviewing those skills. Obviously, it's going to be fresh for the juniors and a little bit longer for the sophomores. But instead of doing one day, I'm just going to do it all one day. And we're just going to review some of the skills that maybe, especially geometry stuff, that you haven't seen for a while that'll help you with that test prep stuff. Okay, that's Friday. And then Monday, I don't see you. Teacher work day. Tuesday will be the part 2 of your test. So your kind of homework over the weekend is going to be to review the other stuff. Okay, which again, we'll talk about more tomorrow and Thursday. All right, so we're going to pick up where we left off, which is rational functions and asymptotes. Part 2, starting with the slant. So a slant asymptote, okay, occurs when the degree of the numerator is 1 more than the degree of the denominator. So when the highest exponent in the numerator is 1 more than the highest exponent in the denominator, there is a slant asymptote. The equation of the slant asymptote, it is a line. So the equation is a y equals mx plus b. Psi, probably when we're done, I'm hoping to, okay? So don't forget if I've got a couple of seconds. And if not, then I'll do it on the video, but just remind me at the end. He asked if we have time for homework questions. Okay, to find that equation, you're going to divide your numerator by your denominator. And then the quotient part of it is your slant. You totally ignore the remainder. I don't know why it works, but it works. You totally ignore your remainder. And just the quotient, so the top part of your division, becomes the equation for your slant asymptote, which again is a line. So y equals mx plus b. Now, if you relate this to the horizontal asymptotes, you remember if the numerator was bigger than the denominator, there was no horizontal asymptote. So you cannot have both a horizontal and a slant. You can have a vertical and a slant. You can have a horizontal and a vertical, but you cannot have a horizontal and a slant, because a horizontal doesn't happen if the one in the top is bigger than the one in the bottom, and a slant happens if the one in the top is one more than the one in the bottom. So if I had x to the fourth over x to the third, there's no horizontal, but there's a slant. If I have x to the fourth over x to the second, there's no horizontal and no slant, because it's more than one bigger. Does that make sense? Obviously, these simplify, so let there be a number at the end. So you get the concept, okay? So this would have a vertical, well, actually it doesn't even have a vertical. This would have a slant. This would have no horizontal. This would have neither slant nor horizontal. Yep.
But with horizontal, isn't it when the numerator is higher than 2, it's like y equals 0 or something like that?
Other way around. If the numerator is smaller than the denominator, it's y equals 0.
And then when they're equal, it's that
The leading coefficient. But if it's more, there's none.
Okay.
Yeah. So you can't have a horizontal slant. All right, so this one just says find the slant asymptote of the function x squared plus 6x plus 2. The fact that this is 2 and this is 1 tells us there is a slant. And then to divide it, we would just do the numerator divided by the denominator's missing the constant, so it'd be x plus 0. So then first times first, x times both of these, x squared plus 0x. Change your signs, cancels 6x plus 2 plus 6, multiply it by both. As long as that first term cancels, which it does, you don't even have to look at your remainder because it's not important for slant. What is important is the quotient that we got at the top. So it didn't say to graph it. I'm not going to go all the way through, but think about what would happen. This would have a vertical asymptote at x equals 0. And a slant asymptote at x plus 6. So 1, 2, 3, 4, 5, 6. My vertical asymptote, my y-intercept is there. Slope is 1 over 1. So I'd have asymptotes that crisscross like that. Your graph is always going to be in opposite corners when there's a slant. So it will either be here and here, or it will be here and here. Our zeros.
How do we know it's a 1 over 1?
How do we know the slope, you mean?
Yeah.
Yeah, so this is my y equals mx plus b, right? So my b is 6 and my m is 1.
Oh, okay.
Yeah. So this doesn't have zeros that are like factorable. You would have to use the quadratic to get these zeros. So we're not going to do this example because we'll look at that in a second. But that's the idea behind them. Slants always opposite corners. Okay, they always crisscross.
And slants can't be crossed like horizontal, right?
Right. Oh, right. Yes. You mean like when you do, like you can't cross through them? Is that what you mean?
Yeah.
Yeah. No.
Yeah. Okay.
Okay. One more. Just the asymptote. So I take that x to the third minus 1. I'm missing terms this time. X to the third plus 0x squared plus 0x minus 1 would have to get divided by x squared plus 2x plus 2. So I have to multiply by x. I get x to the third plus 2x squared plus 2x. Change your signs. Negative 2x squared minus 2x. Bring down the negative 1. multiply by negative 2, all three, negative 2x squared minus 4x minus 4. Change your signs. Again, as long as the first one cancels, I can ignore the rest and look at my the quotient, which is y equals x minus 2. Questions on this one? So this time the exponent in the top is still one more than the bottom, but it was a cube and a squared. It still has to result in an x to the first in the top, otherwise it's not a line.
So it only has a slant if the top is
One more.
okay.
Yep. If it's not one more, then you get something like x squared as your quotient, and you can't have a parabola as a slant asymptote. It has to be one more. All right, we're going to put it all together. So horizontal, vertical asymptotes, slant asymptotes, and holes. Graph the function, use a graphing utility to verify. So first thing I'm going to do is, these are factorable, so I'm going to factor it, make sure it doesn't simplify. This would be x minus 4 and x minus 1. The bottom would be x plus 2 and x minus 2. Does any of that simplify? No. If it did, that's where your hole happens. Okay? So there's no holes. That I know already. So it will look like this. Vertical asymptote, horizontal asymptote, zeros, y-intercept, domain, holes, slant asymptote. There's none here. I'll put the word none. Now I go vertical asymptotes. So set my denominator equal to 0, and I get x equals negative 2 and x equals positive 2. That also tells you your domain, right? That's what x can't equal. So I would say negative infinity to negative 2, negative 2 to positive 2, 2 to positive infinity. So that one step tells you both those things, the vertical asymptote and the domain. You with me so far? Okay, now I go horizontal asymptote. What happens when both the numerator and the denominator are the same power?
A over B.
Good, leading coefficient 1, right? So there's a 1 here and a 1 here, which means it's y equals 1. Slant asymptote, none. Because if the exponents are the same, if there's a horizontal asymptote, there's no slant. Zeros come from my numerator, so I already factored it. I'm going to say x minus 4 equals 0 and x minus 1 equals 0, and my zeros are at 4 and positive 1. Remember, zeros we list. No duplicates of multiplicity there, right? So they're going to cross through those points. Y-intercepts, I plug 0 in for x. This is gone, and I end up with 4 over negative 4, which is negative 1. Still good? Okay, now I'm going to put all that stuff together. All right, vertical asymptotes at -2 and +2, horizontal asymptote at y equals 1. There's no slant. My zeros are at 1 and at 4. And my y-intercept is at 0, -1. Question so far. Does this have symmetry? What would happen if I plugged in a -x, right? -x squared minus 5 times -x plus 4 over -x squared minus 4. This cancels, so I end up with x squared plus 5x, oh, this is -x, plus 5x plus 4 over x squared minus 4. So some of my signs change, but not all of them, right? And none of them, they don't all go back, which means no x-axis symmetry, or y-axis symmetry, okay? So that tells me this isn't a parabola in the middle. There was no bouncing, and there is no symmetry. Does that make sense? Which means this is probably a cubic function. My guess says it's a cubic function here, and because it crosses through here, but there's no 0 over here, that it's probably like that. Cubic functions in the middle, one goes up and one goes down on the outside. It's consistent with not having a 0 on the left and having one on the right. But if this test question is 22 points, you bet your butt you're going to plug in some extra points and make sure. So I'm going to, yeah.
So the horizontal one you can cross, but the slant one you can't?
Correct, and not the vertical one.
Okay, thank you.
You're welcome. Okay, so I'm going to plug in a point to the left of that horizontal asymptote, -4, -3, doesn't matter what you're plugging in. Okay, I'm going to plug one in there. Get my equation back. So, -4 squared minus 5 times -4 plus 4 over -4 squared minus 4. 16 plus 20 plus 4 over 16 minus 4. 36 plus 4, 40 over 16 minus 4, 12. So this is 3 4/12, or 3 1/3. So it's consistent with what we thought. We're above the axis, or we're above the horizontal axis there, horizontal asymptote. The only other thing I would probably do is plug in a -1 just to make sure my cubic function looks like what I think it's going to look like. So -1 squared minus 5 times -1 plus 4 over -1 squared minus 4. 1 plus 5 plus 4. 1 minus 4. 10 over -3. -3 1/3. Down here, just like we suspected. Cubic shape in the middle. This definitely passes through here, so I know that shape already.
Mr. President?
Yeah.
Do you have an example of like what a slant asymptote would look graph?
Yeah, I'm going to add it in. Yeah, I'll do it next. I'll add one in. Okay, so I'm going to put this in my graphing utility, x squared. I would recommend you practice on either your app or your handheld, whichever one you plan to use, so it doesn't take you longer because you haven't practiced the calculator part. All right, so I typed it in. This is what it looked like. You have to do the parentheses for the numerator and the denominator. X squared minus 5x plus 4 divided by x squared minus 4. And then graph it, and there's my curves. Okay? So just to confirm it, I will not be grading handheld graphed calculator pictures for your test. You have to show me all that other stuff. Okay? So just keep that in mind.
Wait, can you repeat that? My mic's
Yeah,
low.
like if you turn in a picture of your graph from your graphing calculator and have none of the other work, I'm not giving you credit for that question.
Right, because we got to show you the...
You got to give me all the other parts. So it's going to ask you for the intercepts. It's going to ask you for the asymptotes. It's going to give you all that stuff. And then you're going to graph it. Yeah. And I expect, like, you can use symmetry to help you eliminate points, but you will be plugging points in on certain parts.
Okay, and so, yeah, you want to actually physically graph it, right?
Correct. Correct.
Put the calculator.
Yep, you're graphing it by hand.
Alright.
Yeah. On the, like if you're using your iPad, it's a PDF. You'll literally open it up and you'll work right on it. If you're not using the iPad and Notability to do work and you're using it by hand, you're going to make your scrap paper look like the paper that is that PDF. If you're physically here and you want a PDF printout, I will give that to you. So I'll just print out the paper and then you'll just take a picture of it and submit at the end, okay? But it is a file upload at the end, so it's not a picture, one picture. You have to take the pictures, you have to pull them into Notability and then upload them if you're doing it by hand, okay? It is a file upload, not a picture upload, because it's 2 pages. Questions?
How many questions is this?
Overall, I mean, this is one question, right? So it's got multiple parts. There's 4 on what you're doing Thursday. 1, 2, 3, 4. Yeah, there's 4 on what you're doing Thursday. And then there's,
Do you have the whole class to do?
no, I'm giving 30 minutes. If I'm dividing it over the 2 hours, it still has to add up to the 50 minutes that a regular test should add up to. So I might do 30, but not more than that. Yeah, no, the whole goal is to come in, get settled, get them in, and not have to be stressed out. You'll get 30 minutes to do those 4 questions. And then the next week, 20 minutes is technically what I should give you. I might give you the 30 just so we get everything uploaded, but yeah.
So it's 4 of this same question, just like.
No, it's 2 graphing questions. And then it's like a complex answer that's so ugly you can't like write that as an answer, so I'm just doing the upload. And a zeros question. I'll talk about it when we do the review. Like when we go through the review, I'll tell you these are going to be on Thursdays and these are going to be on next Tuesdays. Okay, so let me do an example. Let me actually make sure I can graph it. Let me do an example with your slant asymptote, just so you get an idea. That would give you a whole, let me see. Okay, so I'm going to change this to the denominator so that we have some of the work done already. X squared minus 5x plus 4 over x minus 2. So just change the denominator so that it's got a degree of 1, but you can't make it minus 4 because then you'd cancel and get a whole. So what's different now is my vertical asymptote, because if I set this equal to 0, I get my vertical asymptote at x equals 2. Super hard to read, huh? My zeros would still be x minus 4 up here, x minus 1, so it'd still be 1 and 4. This time there's no horizontal asymptote. There is a slant asymptote because the exponent in the top is 1 more than the bottom. So I take my x squared minus 5x plus 4, divide it by x minus 2. First into first, this is x. Multiply it out. Change your signs, cancels, negative 3x plus 4. Multiply it out, negative 3. Change your signs. As long as that first one cancels, which it does, I don't even need the end of that remainder. This is my slant asymptote.
How come there wouldn't be a horizontal asymptote?
Because the exponent in the top is bigger than the one in the bottom. So remember, if they're the same leading coefficient, one in the top is less, it's 0. One in the top is more, there's none. Okay, y-intercept, plug 0 in, 0, 0, I'd get 4 over, this is 0, negative 2, negative 2. Y-intercept, remember intercepts are in coordinate point form, zeros are listed. Domain, negative infinity to 2, 2 to positive infinity, and there's no holes. Yep.
If there's a hole, do we still put, the original for the long division or the new one?
For the long division. There won't be if there's a hole and a slant, you put the simplified one. I don't know if I'll do that to you. Yeah. The question was if there's a hole and a slant. I mean, it's possible. Yeah, but I don't know that I'll do that to you. You would simplify it which would mean it has to be a third in the top and a second in the bottom. That reduces and it's still a second and a first, because it still has to be one apart, even after you cancel it out. And then if it cancels out, that hole is gone. So on the slant, on your curves, when you're graphing it, there's gonna be a hole on one of those curves. So you'd have to plug in that 0. I'll see if I can do an example in a minute, yeah. All right, so vertical asymptote is at x equals 2. Slant asymptote,
Holes only happen when when you like simplify it down, like it's able to be factored.
so if I had started with this, right, then this would have been -4, -1.
Right, and then the minus.
These cancel. So I'm graphing a line now,
Right.
and there'd be a
But-
hole.
Right, because of the x can't equal 4, right?
Exactly. There'd be a hole at 4. 1, 2,
Okay.
3, 4.
Alright, make it fair.
There'd be a hole here. It'd be like that.
Right, okay. Thank you.
You're welcome. Okay, so vertical asymptote's there. Slant asymptote is x -3, so I go -3 up 1 over 1. Here's my slant asymptote. And again, they're in the crisscross corners. So it's either top, right, bottom, left, or top, left, bottom, right. If I plot my zeros, which are at 1 and 4, and my y-intercept at 0, -2, I already know what corners they're in. If there were no zeros, like if my numerator resulted in like quadratic, that when I actually use the quadratic formula, there's i's, and there's no zeros, then I would know it's here and here. I'd have to plug in points. I'd still have a y-intercept that time, okay? But I'd have to plug in the points to make sure that it's in those corners. But that's how that kind of happens. Like if there's no zeros, it's not crossing the x-axis. That helps you. Questions on any of that stuff? Good morning, Mr. Saxton.
Everybody. You having fun yet?
All right, Sai, you have a question on the homework?
Yes.
Can you tell me which one?
Let me.
All right, find any asymptotes and holes in the graph of the rational function. Verify your answers, comma separated list in an answer that doesn't exist, any. So I have to take this and factor it first to see if there's holes. So x plus 1 and x plus 1 is my numerator. Denominator is 7x, x, -8, +1. Yeah, so 7x minus 8, x plus 1. So as soon as these cancel, there's my hole. -1. Now your vertical asymptotes is reduced to just this one. 7x would equal 8, x would equal 8 over 7. There's my vertical asymptote. The slant asymptote comes from, or sorry, the horizontal asymptote comes from my reduced function. So once I get that hole, I'm done with my initial function. Now I'm graphing this. So the exponents in the top and the bottom are the same, which means it's the leading coefficient 1. 1 over 7 would mean that my horizontal asymptote is y equals 1/7. So there's my vertical, there's my horizontal, and my hole at -1. Now if I'm graphing this, 8/7 is just past 1. 1/7 is really tiny here. Okay, and there's a hole at 1, but I have to figure out exactly where that is. So I have to, or -1, I have to take -1 and plug it in. And I get 0 over, it doesn't even matter, -15, it's 0. So at 1, 0 here, there's a hole, which tells me my graph is probably doing this and this, which I would know further by finding the other holes and that kind of stuff. I mean the other zeros and other points. Yeah.
Is there maybe, besides plugging in points, is there maybe a trick to like, you know how like if you have like positive like x squared.
If it's in
equals six,
standard form, yeah. But if it's not in standard form, no.
like if like how what about how like the
Like positive, right, like your A, like the term on the front, like if they're both positive, then usually it's top right, bottom left.
Yeah.
Yeah, but that's only if it's in standard form, and a lot of times it's not giving you in standard form, so that's the hard part.
Okay.
Yeah, usually, like look at these, they're both positives, right? Both positives are usually top right, bottom left. But if it's out of order, you gotta pay attention to the squared term or the first term. That usually still applies. Positives, top right, bottom left, like it points up and down, right? So up, right, down, left, just like a cubic function or anything like that. If it's positive, rises right, falls left. That's usually true.
Okay.
Yeah.
Thank you.
All right, folks, 9:50. Time flies when you're having fun. C period, stop staying home.